But my hope will never die.
What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines, as we are looking to conclude our series of videos on arithmetic sequences. Today we're going to look at a quick application of arithmetic sequences. So let's jump right into an example problem. I have the two formulas that we have been using for arithmetic sequences. Here on the left we have the formula for a partial sum or a series of arithmetic sequences, and here on the right we have the explicit form for any term within an arithmetic sequence. So we're going to use both of those in problem 8. Problem number 8, which may be number 9 on your notes if I remember correctly, states that Cox Auditorium is an amphitheater that has 40 seats in the first row, 42 seats in the second row, 44 in the third row, and so on. If there are 75 rows in the auditorium, what is the auditorium seating capacity? So what we have here is that we notice that this auditorium would be something like this kind of format. Okay, so just a quick sketch here. You can see that the rows, as we see the numbers here, the rows are increasing in size with each row. So the first row has 40 seats, the second has 42, the third has 44, and we may see a pattern emerge here. The fourth row would have 46, the fifth row 58, and it would go on and on and on in this direction for 75 total rows. So what we could do if we wanted to find the seating capacity, we could find each of the, or we could add together each of the seats in all 75 rows. This would take us a while. But what we may realize instead is that this is an arithmetic sequence. Each time the numbers increase by 2. So what we can do here is we can create a formula and use the partial sum formula to find the total number of seats. So let me move this diagram over here a little bit so we have some space to work. So what we want to find here is the partial sum, or the sum for the first 75 terms. So if I substitute into that formula, I'm going to need n, which is 75, the number of rows in this case. I'm going to need to know the number of seats in the first row, the first term, which is 40. And then I'm going to need to know the number of seats in the last row, the 75th row. And we'll take the average of those two and multiply that times 70. Now, finding the terms in the 75th row is going to be a little bit difficult. Again, what we could do here is we could start with the first row and add 2 all the way up to the 75th row and count out all those numbers. But instead, we can use this formula for any term, the explicit formula for any term of an arithmetic sequence. So what I'm going to do is try to find a of 75. That number needs to go here. So a of 75 can be found by taking the first term, 40, plus the difference, and we can see that the difference is a positive 2. The length of the row is increasing by 2 seats each time, times n minus 1, or 75 minus 1. And we can evaluate this expression. So 40 plus 2 times 74 would be 188. So in the 75th row, there are going to be 188 seats. So if we want to find the seating capacity of the entire amphitheater, we can do the partial sum for rows 1 through 75 by evaluating this expression. So this would be 75 times, let's go ahead and type all of this into the calculator, 40 plus 188 over 2. I wrote this down incorrectly, so hopefully you noticed that there. This number in the denominator should actually be 2. And this gives us the total number of seats. So there are 8,550 seats in total. And so that would be the seating capacity. So again, you could have found that number by starting with row 1 and taking 40 plus 42 plus 44, and going on and on until you got through the 75th row. Or we can use a combination of the partial sum formula and the nth term, or the explicit formula for any term within this arithmetic sequence. So here's just an example of how we can use arithmetic sequences to solve problems. As always, thank you guys for tuning in, and I'll see you soon.